For this particular section, let's talk about power functions and how power functions will relate to our polynomial functions that we'll be doing in one of the next videos. Power functions are basically polynomial functions, but just the first term. So we're going to go through and identify what a power function is, and then we're going to identify the end behavior of power functions, because we'll use those as we start dealing with polynomial functions. So getting started, here's our first example. It's to sketch the power function y equals negative 3x squared, and then describe the end behavior. All right, so first off, before we even start getting into much of this, let's start talking about what do these different parts mean. So if I look here, this just looks like the first term of any quadratic function. And we know what a quadratic function is going to look like, so I'll just down here in the corner, we know a quadratic function is going to look kind of like this, just a regular quadratic function. But in this one, we have a first term that is negative 3. That's our leading coefficient. And again, we already see that we have a 2 here as our exponent. So first off, we want to start talking about what does this 2 mean. Now that I've kind of blocked it out that you can't even see it, but what does that mean? So that is known as, for the stuff we're going to start talking about in this section, this is the degree of the function. The degree of the function is going to let us then figure out how to describe the end behavior. All right, so let's go through and we'll start plotting some points, because that's the easiest way for us to go through and do these. I'll figure out my x value, figure out my y value. We're going to go to either side here. If I were to put in a negative 5 for now, I mean, substitute a negative 5 in there, and then I'm going to square it and then multiply by negative 3, I'm going to be nowhere on here. So we'll just start with negative 2, negative 1, 0, 1, 2. All right. If I put a negative 2 in there, negative 2 squared is going to give me 4. And then 4 times a negative 3, well, that's going to give me then negative 12, sorry. Substitute a negative 1 in there, that's going to give me 1, because negative 1 times itself is 1, and then times negative 3, so negative 3. Put a 0 in there, it's all good. Put a 1 in there, we square it, same exact thing. None of these numbers now for the next should be surprising, because of the fact that this is a quadratic, and it is symmetric about the y-axis. So actually, before we get started, let's drop in our axis of symmetry. See if I can get it to, let's see if I can get it to line up nicely. Let's see if I can just get it to not pull it all over the place. All right, try this again. There we go. All right. So here is our axis of symmetry. All right, and I'll grab this point and I'll pull it up. Hopefully. There we go. Pull this up so we can really see that we're looking at the axis of symmetry. Now I'm going to plot these points. So at negative 2, 1, 2, I would be all the way down here at negative 12, which actually is about there. And then if I'm at negative 1, I'm down here at 1, 2, 3. And then at 0, 0. And then I have my mirror on the other side. This is like down here. So I'm just going to do a rough sketch. All right. And then go the other direction for the other part of our rough sketch. All right, and we see that we have a parabola. And it makes sense because we're used to the parabola here based on the second. And then we know this is negative, so we know the parabola is going to open down. And then we would expect it to go rather quickly because of the 3 in front. So we know a lot of these different things. Now, when we start talking about end behavior, what we're talking about with end behavior, I'm just going to erase this down here, is what happens as x gets large? What happens as x moves to negative infinity? So that's what we're actually going to write here. Okay, so as x approaches infinity, in other words, as we move out this way, what is the value of the function doing? Okay, and that's what we mean by end behavior. Well, as x moves towards positive infinity, the value of the function is going to move towards negative infinity. You see how the function is continuing to go downwards. As x approaches negative infinity, so as we move our way this way, what's happening with the function? I'm going to have it go below just so I don't run into it there. F of x is going to approach negative infinity as well. And that's because these are going in the same direction. And actually what's going to happen, if this number here, our exponent, which is our degree, if that degree is even, they will go either both up or both down. If it is odd, they're going to go opposite directions. All right, so let's take a look at another example, and we'll explain this again, same exact thing. Here we've got an x cubed, so that means the degree of this function, the exponent is 3. So we kind of already know what a cubic would look like. I'll go over here in the corner, and a cubic function would look like this, and we know this from our family of functions already. So this is of that family of functions. Our leading coefficient is 1/2. Our degree is 3. So we know it's going to look like this. So let's take some points. We'll just substitute them in. We'll choose points that we know will work. So I'll use kind of similar ones as before. So -2, -1, 0, 1, and 2. Substitute -2 into here. So -2 times -2 times -2 is -8. And then I'm going to divide that by 2, because that's what multiplying by 1/2 means. And I end up with -4. Substitute -1 in here. -1 cubed is still a -1. And then -1 times 1/2 will give me a -1/2. Substitute 0 in here. With all power functions will go through the point 0, 0. So that will make life a lot easier when we go through and do these. Substitute 1 in, it stays positive, so I end up with 1/2. Substitute 2 in, 2 cubed is 8, half of that is 4. If I went with 3 here, the reason I didn't go with -3 and 3 is because 3 cubed is 27. I'm going to take half of that. It's not going to fit in my window. So let's plot these points. And again, we're just sketching really. So here at -2, I'd be down here at -4. At -1, I'd be at -1/2. 0, 0. 1, 1/2. And 2, 4. All right, so I'm going to, again, this is a sketch. I'm not really too worried about how exactly it looks, but I do want a rough idea. And go ahead and finish that. So there's what it looks like. And that makes sense because it is based off of our family of functions of cubics. So all the power functions we're going to do are going to be based off of quadratics, cubics. So any odd degree will have this similar shape. Any even degree will have the similar shape of what we had in the last problem. So with this, when we start talking about its end behavior, all right, end behavior, as x approaches infinity. So as we move our way along this axis, what is happening to the function? As we move this way, my function is continuing to move upward and outward. So then when we go and finish our expression here, so as f of x goes to infinity, as x goes to infinity, f of x approaches infinity. As x approaches negative infinity, so as we move along this way, because we're talking about the end behavior, what happens as x gets large in a positive direction, what happens as it gets large in a negative direction. So as x gets large in the negative direction here, then our function is also heading towards the negative value. So f of x will also approach negative infinity. So just as a separate example, all right, and not using the drawing or anything else, let's say that I had g of x was equal to just, I don't know, x to the 6th. And I want to know, what does the end behavior look like? Well, we have an even degree. It has a positive value here. That means that our graph should do this. So then when we talk about our end behavior as x approaches infinity, right, as we move this way, then so does our function. So in this case, actually, it's g of x would also approach infinity. As x approaches negative infinity, so as we move this way, g of x approaches, again, the same direction, infinity. That's all we're talking about when we talk about end behavior and power functions. And this is just going to be used to help us with all of our work dealing with polynomial functions next. All right. Thank you again, Robert Main, down here at Chariho. If you have any questions, comments, or anything else, just go right ahead and send us a message. Thanks again. Bye.